Let's add and subtract some polynomials. Addition is really just combining like terms, and we've done this before. These may look a little longer than what we've done. The like term part has to do with this exponent and this variable. Make sure they both match to be like terms. So if I have 7x to the 6th, and I also have 21x to the 6th, then all together I have 28 of those. And so we write it like that. And you go across and find anything that matches. Now I have x to the 5th, no x to the 5th over here anywhere. So that's going to stay the same. It's like 5x to the 5th plus 0. What's next? I have negative 2x to the 3rd. Wait a minute, there's something missing between here and here. But there's an x to the 4th term over here. So this is like 0 minus 11x to the 4th. So I'm just going to write minus 11x to the 4th. Next is x to the 3rd here and x to the 3rd here. Be careful because these both have negative signs in front. This is subtraction, but it's also like adding negative 2 and adding negative 5. So if you think of it like this, then we have a negative 2 and a negative 5, and all together that's negative 7 x to the 3rd power. How about x squared? We only have one little x squared over here, so we're going to add x squared. And we don't have a constant term in this one, but we do right here. So I have a plus 12 on the end that is unchanged. So addition is just collecting like terms, but do be careful with individual subtraction signs in the polynomial. Think of that as a negative number. Notice that when I wrote out my answer, I wrote them in order of the exponents from the largest down to the smallest. This 12 without an x is also like x to the 0 power, so it goes at the end, even though we don't write it that way. Remember, x to the 0 is equal to 1. 1 times 12 is 12. So when you're writing your answer, you need to arrange it in descending powers of the main variable. Let's try the second example. So we've got 3x squared and minus 6x squared. 3 minus 6, that's negative 3x squared. And here we have something unusual. So look at this. We have to match that variable exactly. Here it is. Now when there's no number in front, that's like a 1. So I have 4 plus 1 is 5xy. And then I have a y squared. So we've got negative 2 and negative 6 all together. That's negative 8 y squared, which I wrote as subtraction. Now subtraction is a little different. We are going to collect like terms, but when you see subtraction between polynomials, the first thing you need to do is think of that as negative 1 times everything. So we're going to change it to one big addition problem. I've got my first polynomial plus the opposite of everything in the second polynomial. So that negative in front of the parentheses, we're going to distribute to all of these. Let's do that. So instead of 3x cubed, I have negative 3x cubed. And instead of subtract x squared, I have add x squared. 3x turns into minus 3x, and plus 1 becomes minus 1. Now collect like terms. So for cubes, I have 8 minus 3 is 5x cubed. For x squared, I have a negative in front of the 2 and a positive 1x squared. So if you combine positive 1 and negative 2, you get negative 1x squared. For the x term, I have a positive 4 and a negative 3. 4 minus 3 is 1x. Put a plus in front of it to separate the terms. And negative 7 minus 1 is negative 8. That is the final answer. In our last example, let's rewrite that second polynomial, multiplying everything by negative 1. So I've got minus 3x cubed minus 11x squared minus x and plus 4. What if we wrote it this way? Match up the terms. I'm just writing them below the ones they match. You can think of it as adding like this. So for the x cubed, I've got negative 8x cubed. For x squared, I have negative 13x squared. I'm just adding straight down. Positive 3 minus 1 is 2. Put a plus in front of any positive numbers that you get. 1 plus 4 is 5, and that's our final answer. So there's addition and subtraction.